Hello, everybody. Welcome. Nice to be with you, kind of. This is 2016 FRQ number 3. I'm not doing a video on number 2 since it will not be tested on the 2020 AP exam. So I went from 1 to 3 because that was your homework assignment. So here's question 3. Let's read through this a little bit here. It says, the figure above shows the graph of a piecewise linear function of f from -4 to 12. -4 to 12, this is f. The function g is defined by this. So g is this function. Oh, whenever I see an upper bound of x, I'd be willing to bet that the fundamental theorem of calculus is involved. I would say 9 out of 10 times that is true. So let's just read the question. As I unpack these questions, make sure you listen very carefully to how I model what I would be doing if I were to do this FRQ. So the question is, does G have a relative minimum, a relative maximum, or a neither at x equals 10? And then don't forget to justify. So as I'm reading that, I'm thinking to myself, how do I tell if G has a minimum or a maximum? Well, minimums and maximums and neithers are when the derivative is 0, but it must change from positive to negative or negative to positive to be maxes and mins. And if it just keeps increasing like this, it's a neither kind of situation. So that's the goal. So for G to have a minimum, maximum, neither, I need to find the derivative of G. So how do I take the derivative of G? Well, that is the fundamental theorem part. Somewhere on your paper, you must then, since this is the graph of f and not G, and your question is about G, you must link f with G. So the fundamental theorem says, if I was going to take a derivative of an integral, which I am, I'm taking this derivative here of an integral, and the lower bound is a number and the upper bound is an x, all I need to do is put this x in for my variable. So this is f, so this is also the graph of G prime. So I'm going to need that. All I need to do is label this once, and then I can refer to f or G prime simultaneously anywhere within the project. So as I'm doing this, the 1 point, look on your paper, somewhere you had to have made that link. If you did anywhere, you're good for that point. And then the second point, the answer is neither. Well, why is it neither at x equals 10? The reason why it's neither is because right here at 10, f, which is G prime, stays negative. So that means it's kind of like this situation here, but it's actually decreasing because G prime is negative. It gets to 0, so it just levels off for a second, but then dips down again. So that's one of those neither situations where the derivative equals 0, but does not change sign. So that's part A, 2 points. Part B, does the graph of G have a point of inflection at x equals 4? So here's where I'm thinking x equals 4, but this is the graph of f, which is also G prime. So let's just think for a moment. How do I tell if something has a point of inflection? Point of inflection, second derivative must change sign. So my question is, how do you figure out if the second derivative changes sign when you're looking at the first derivative? So when you're looking at the first derivative, the derivative of that, G double prime second derivative, will change sign when this function changes from increasing to decreasing or decreasing to increasing. So answer is, does the graph have a point of inflection? The answer is yes. So somewhere you have to say, yes, it does have a point of inflection, or G has a point of inflection, etc. So that's the answer part. But to get that, you also need the justification. The justification at 4 is because you're increasing to the left of 4 and decreasing to the right of 4, you will have a point of inflection because then G double prime will change sign. If you just talk about G double prime and you say G double prime changes sign or G double prime goes from positive to negative, you will not get points because you're not talking about what's given to you. Since you're given G prime, you have to speak about G prime. Now, if you add the caveat that a point of inflection will occur at x equals 4 because G double prime changes from positive to negative, I know this because G prime, or F, is increasing and changes to decreasing at x equals 4. That's a really good, long, clear answer, but you just have to say this stuff. Increasing to decreasing at 4 for G prime. 1 point only, not a big deal. Part C, find the absolute minimum value and the absolute maximum value of G on the interval -4 to 12. Well, this one's probably the trickiest part of the question. To find an absolute maximum or an absolute minimum, almost always, I would highly recommend you use the candidate test. So in this case, we need to know, because we're talking about G here, we need to know a value for G somewhere. So since G of 2, because if I put a 2 in here for x, I'm going to get an integral from 2 to 2. Sorry, it's a little sloppy, but I was writing with my mouse. That will equal 0 clearly. So I know right off the bat by making my candidate test here on my table that I know that if I put a 2 in my table, which would end up being right here, that I'm going to get a 0, which is right here. Now that's not a key point because that's not where, it's not an endpoint, nor is it a place on the graph. If you're looking here at 2, it's not a critical point because at 2, f or g prime does not change from positive to negative. So what are my key points? Endpoints, -4 and 12, and let me change to a highlighter here. Here and here. Those are key points because your derivative changes from positive to negative or negative to positive at those points. So all I need to do is find their values. So remember, at 2, you have a 0 here. So now let's go forward. It's easier to go forward. So if your value at 2 is 0, what's your value at your critical point here? Going back to my pen. What's your value at your critical point right here? At 6. So if at 0, G is 0 because of this, then it will accumulate 8 units of area. Well, how did I get this 8? This is a triangle, which is going to be 1/2 base, which is 4, by height, which is 4. 4 times 4 is 16, half of 16 is 8. So this area is 8. That means its displacement is 8. So when I move from 2 to 6, it will move 8 units up. So if I was at 0, 8 units from 0 is 8. Now, going backwards in time is kind of like reversing. So this means I'm going up 8 units from -2 to 2, but if I'm going backwards, then I'm actually going down 8. That's how I get this -8. And then let's go forward one more time. So if I knew that the 6 gives me an 8, then I went down 8 from the 8, so I'm at 0. And then I went down another 4, so that I'm actually at -4. So I hope that all makes sense to you. Now going backwards again, let's kind of rethink this. If I'm at 2, t equals 2, and then, or x equals 2, t, x, interchangeable, doesn't matter. So if I am at 2, I get 0. Then if I go backwards, this gets reversed. I'm going down 8 by going backwards in time. So I'm at -8. And then here, I'm actually going up when I go backwards because it's down when I go forwards. So this -4 is actually a +4. So these signs get inverted. So going backwards, I go -8 plus 4, which gives me a -4 down. Making this table is crucial, key, it's important. So now let's look at our rubric and how we score this. If you considered those interior key points somewhere on your paper, all you have to do is put them on a table, you get the first point. If you considered your endpoints anywhere on your table, -4 and 12, you get the second point. What is the answers? The answers are, you have a minimum at -2. Now, do I need the minimum values? Oh, I do need the values here. So since I need the values, I need the actual y values. That's why I was going to make this table. So I'm looking for the minimum, and I'm looking for its value as -8. That's the lowest in my table. And I'm looking for the maximum, and its highest is a +8. And those are your two interior points. So since you're looking for mins and maxes, you have to consider both of these two little pink dots here, and you also have to consider the endpoints, but in those cases, they were not the absolute mins and maxes. Part D. G, for all 4 to 12, find the intervals where G is negative. Okay, this just basically means negative. Well, you know what? I did all the work on the last problem. So I'll just go through the answers first because you get the 1 point for each interval. So if you got -4 to 2, you get a point. If you got 10 to 12, you get a second point. That's it. Very simple to grade that. And if you need a y explanation, I'm going to go back. That's kind of why I made a graph of this table here. So I am looking for when G is negative. This is my quick little sketch of G. I put the dots here. I would have done this much quicker with a pencil by using these values. So at -4, I went down to 4. At -2, I went lower, -8, just pointing all these points. So one more time, what's the question? When is G negative? So let's look at this. G is negative here, and G is negative here. So now I clearly have two little spots. So now how do I write that interval? The question is, when does this hit 0? Well, you know what? We kind of thought about that already up here. It hits 0 when x equals 2. So that's the ending point. So from -4 to 2. And how did I get that other spot? A little bit more difficult, but not too bad. So then I went up and I went up and I went down. So let's think about this for a second. I went up 8 and then I went down 8. So if I went up 8, back down 8 in this whole interval, I'm going to be getting back to 0 again, and it happens to be at 10 and stays 0 to the end of the interval. There you go. That is 2016 FRQ.